Hey everybody, so let's shift gears a bit and look at another piece of the puzzle to make 3D work, and that's our camera model. So we've already learned how to do a camera model in 2D, but things change in 3D, so we need to revisit this. But if you don't remember the 2D stuff, it is worth your time now to go back and review that. So it is similar to 2D. If you're confused by the 2D camera, go back and check it out. So the idea of the camera model is we need to move our view around the world, right? We have a world, we put objects in the world, we have a projection which puts it to screen. In the middle is our camera, and we need to move it around the world somehow. And just like in 2D, there are two approaches. Let's try that again. Two approaches, okay? So first, we can just point the camera at a fixed location and move things around it. This is actually more common than you might think. Point the camera at a fixed location, and then we move the world around. So imagine a simple racing game where the track just keeps moving along. So I point the camera at one spot, and then at the beginning of either at the end of the view matrix or at the beginning of the model matrix, I put a translation to move it along. So you just move the world along, and everything in the world gets moved by that translation. So it's really simple to do. So I point camera at a fixed location, and I move the world around. Okay, by adding, I should spell that out, by adding transforms. To the view or the model. Okay, so it'll look something like this. I have my 3D coordinate system. This is my x-axis, my y-axis, and this is z going negative into the screen. And then what we do is we just put the camera here somewhere. Okay, here's my camera, right on the z-axis maybe, and I point it there. So in this case, you can put the camera offset from the origin, so it's looking at the origin, looking down the z-axis. Okay, so my camera just sits there looking down the z-axis, and then I can draw whatever I want in front of it and then change those transformations. The positives here is that this is very easy to make. Okay, it's good for simple movements, like on a track, moving sideways. For example, side scrolling. It's good for simple movements. But the challenge is it's hard to make complex camera movements. Right? You want the camera to follow into a tunnel, something like that. Now you have to think, how does the world move to make my camera go through the tunnel? It's easier just to make, it doesn't work that way. It's easier to use a different model. So if I want to do complex camera movements, this basic approach of pointing a camera at a fixed location doesn't work as easily. So just like in 2D, the alternate approach is we model the camera itself. So synthetic camera model. Cool. So this is the same approach as 2D, but now we have to work in 3 dimensions. So same approach as in 2D, where we create a basis function. Transform in and out of camera space. So if we have that function, if we can construct that basis function from the parameters we care about, then it's actually pretty straightforward to modify those parameters to put the camera where we want. So in 2D, it looked kind of like this. We have our up vector, right? And if you recall, we have our perpendicular vector. So it makes a basis function. And then in 2D, we can easily rotate the camera, right? We just modify that. Sine and cosine gives you a direction. You can add a scale if you want. You can move the camera, right? Remember that that's the camera position. Okay, so that's really cool. So that's simple. That's what we do in 2D already. That's a quick recap. So what changes in 3D? In 3D, we need, instead of the 2 orthogonal normal vectors to make the basis, we now need 3. Ooh. We need 3 orthogonal and normal vectors. Normalized, I should say. Because they're not normals, they're length 1. They're unit vectors, right? We need 3 orthogonal vectors. So because we need to consider the z-axis now, which we didn't do before. Okay, so let's draw this, what this looks like. So just like in 2D, we have the up, and we have some kind of perpendicular vector like that. But now we need another z direction, okay, which is also orthogonal to up and also orthogonal to perpendicular. They're all orthogonal vectors. So we can extend what we're doing basically by adding another vector. That's a can. Let's write that a little neater. We can extend our 2D solution. Okay, so we can take this and we say, well, we have this third vector. What should I call it? Well, it's kind of where we're looking, right? It's right in front of my camera. So let's call this look at. This is the vector that tells me where I'm looking, okay? That's my look at vector. And we can just calculate that. It's not hard. We can extend what we have in 2D by saying look at is going to be my up vector, right-handed system, up vector perpendicular, and that'll get the z that way. So look at can be up minus perpendicular. Okay, be careful of I'll come back to this. You know, if I want the vector to go that way, I go perpendicular, I go up. Up and perpendicular, it goes this way, but actually the z has to maintain negative. So if you're actually going to implement it this way, make sure to negative that so we're still looking down the negative z-axis. If that confused you, don't worry about it. We're actually going to come back to it because there's a bigger problem here. So we can do this. We can say, look, yeah, now I have look at, it's orthogonal to up, orthogonal to perpendicular, and we have these 3 orthogonal. We make sure they're normalized vectors. I can make a 3D basis. I can do the 2D model in 3D. It'll work just fine. Okay. The problem with this is not flexible. And it's boring. And it's boring because I'm always looking straight down the z-axis. If I move my camera, it's just like 2D. Nothing has changed. But we're in 3D. I want this look at vector. What if I want to where is it? What if I want to look up this way or spin it z? I should be able to look any which way that I want to. This model that I just showed you doesn't make it easy to do that, okay? Because I have up, I have to think which way do I want up to be. This model doesn't really help you. So it's boring. We want a more flexible way to model our camera. Okay, so I'm going to take a break here. We'll come back and we'll learn a free look camera model.